Hi everyone, in this video let us understand a concept of shared VPC in AWS VPC. Why it is useful, why do we incorporate that in EKS architectures, let us understand in details. Let's get started. Let us say we have one AWS account A on the left side, one more account on the right side which is called account B. Normally, when we have multi-accounts structure in a AWS organizations, it is very common to have various business applications deployed in the respective AWS account for security and networking control point of view. But there are some use cases where it is beneficial to have one VPC in one account that can be shared across other AWS accounts. So let us say we have one VPC which is called Shared VPC created in account B. This VPC will be shared by applications in account A through a service called Resource Access Manager RAM. These resources in account A can be any applications running on EC2, ECS clusters or EKS clusters. All of these workloads will be running in account A but accessing a common VPC in account B. Now, let us understand the benefits of this shared VPC in the first place. We can do a consolidation of the resources across multiple accounts. Though the applications are spread across in different accounts, all of them will be creating their respective resources in the same common shared VPC. So that way, consolidation of all the resources is one use case for the shared VPC. Apart from that, we can do a separation of duties. For example, the networking and security team can implement all the governing policies for the security control and access controls, network topologies, network configuration in a secure way in the networking and security account, while the application team can deploy their applications freely in the respective AWS accounts so that they have different rules and responsibilities for their workloads. Similarly, we can reduce the number of VPCs that we need to create and manage. Creating so many subnets across the VPCs, managing their access controls is always a operational overhead. So we can remove that overhead and centralize the VPC in one account. Another important use case is to have separate accounts for billing and access control. It is useful to control the access and also the billing, the cost to the BU and to the various applications in terms of segmenting the applications across various accounts. Then we don't need to create any VPC peering or transit gateway connectivity to establish the connection between the VPCs because the applications are sharing the same VPC. It is easier and there's a lot of throughput benefits also. Now, since there is no NAT gateway or we are not using any VPC interface endpoints, the AG traffic is also less. So indirectly, we are reducing the cost as well. And there are some hard limits with respect to resource quotas. If you look at a service called Direct Connect, there is a limitation of 50 virtual interfaces. So that limitation can be avoided by using shared VPC. Now, let us understand how shared VPC works. Before we use shared VPC, we must enable the resource sharing from the management account within the AWS organization. So this is important prerequisite before enabling this feature. And then we have the owner account, the account where we are creating the shared VPC, and this account will share the subnets with other accounts which are called participant accounts. The participants account can do CRUD operation, that is create, read, update and delete on the resources that they create on this VPC. Since the routing is happening within the VPC, there is a high degree of interconnectivity between the resources in a shared VPC. So performance is quite better in this case. And the application owners who are creating the resources in the shared VPC continue to own the resources in terms of the access control. But there are some gochas, there are some considerations we need to keep in mind while using the shared VPC. For example, if you want to use separate VPCs for high degree of isolation, if you want to prevent access from one application to another application, or if you have multi-tenant business applications where you need to provide network segmentation, isolation, in that case, shared VPC is not a good idea. And if you use multiple VPCs for dedicated VPC and dedicated account, it's quite easy to create a new business unit applications since you have a reference point. Otherwise, if every application uses the same shared VPC, it's challenging to create a new application. One more thing we need to keep in mind is if you have default VPC or the subnets, those default VPC and subnets cannot be shared across the accounts. Only the newly created VPC and subnets can be shared across the accounts. And all the accounts which are sharing the shared VPC must be within the same AWS organization. Now, let us take a simple use case, how shared VPC gets implemented on Amazon EKS. For example, we have AWS organizations and we have multiple accounts. So one of the AWS account is network and security account and other accounts is workloads account. In the network and security account, let us say we create one VPC called shared VPC. We create subnets, public subnet for exposing the applications to the internet traffic. Then private subnets, this is where the workloads will be running. Private DP stands for data plane, and private CP, which is the control plane. For EKS, we normally create three subnets: public subnets, private data plane subnets for hosting the nodes and the pods, and the private CP control plane subnets. These subnets are used only to create the cluster. We use a service called AWS Resource Access Manager to share this VPC with other accounts. So the Resource Access Manager in both accounts has to be configured to allow sharing. The EKS cluster is created in workloads account, but the VPC and subnets are in the network and security account. Let us say we deploy one node group in the EKS cluster, and before we deploy any pod which requires any AWS resources access, what we need to do is we need to first create something called OIDC, OpenID connector, which is the identity provider which EKS will use to provide identity to the pods. So on the second account, which is network and security account, we are creating a OpenID connector. But normally, if you see, when you create a EKS cluster in an account, in the same account, the OIDC connector is created. But in this case, we are creating in the second account. There is a default OIDC connector which is already created along with the EKS cluster in the workloads account. So we are not using that. Instead, we are creating a brand new OpenID connector in the second account, which is network and security account. So why do we do that? Because let us say we create an IAM role in the network and security account. Because the pods running in the EKS cluster will assume this IAM role through a concept called IRSA. IRSA stands for IAM role for service accounts. That means IRSA will provide an identity to the pods through which the pods will get temporary credentials to access the required AWS resources. Now, in this case, we wanted to create a load balancer or a network load balancer, application or network load balancers in the network and security account. And this pod, which is called AWS Load Balancer Controller pod, running on the EKS cluster, it needs to have access to the network and security account, but it is running inside the workload account. Since it is assuming a role in the network and security account, the role must have a trust policy, and the trust policy should be part of the same account, which is network and security account. So that's why the OpenID connector is created separately in the second account. Then we use AWS RAM to share the VPC that we discussed already. So the pod which gets deployed in the cluster on the left side will assume this role through the IRSA. And through that role, it can provision some AWS resources like security groups and application load balancers through ingress objects. So the AWS LB controller will process the ingress objects and create an application load balancer in account B, which is on the right side. And then the clients can access this ALB through the internet. So this is how we have created a EKS cluster on the left side, which is a workload account. So that means the application developers who are working on the EKS cluster can deploy their applications in workloads account, while the networking team or the platform DevOps team, which is managing the security and the network configuration, the policies, topology, all of that, they can independently control within the network and security account. And one more thing, if the load balancer requires certain ACM certificates, which is Amazon Certificate Manager certificates, or if they wanted to configure some domain names, anything that related to security and compliance, they can independently configure in the network and security account, while the developers can continue to work on the workloads account. So this is how the separation of the duties is possible with shared VPC, still allowing multiple accounts to work together in the AWS organizations. So next, we will go through the lab and start creating a shared VPC in one account and create a EKS cluster on the another account and access this through the RAM service, and also deploy an application load balancer and have some traffic coming to this ALB via internet.